Alright, today we're going to go over 2.1 part 2. It's pages 92 and 93, 38 to 54 even. Alright, we'll start with 38. Alright, number 38 says describe and correct the error. So the error is they multiplied the exponents. Because remember, the bases match instead of adding. Remember, the bases match, you add the exponents. So this should actually say x to the 5th times x to the 3rd equals x to the 8th. And that's it. That's it for 38. Alright, 40, they have the area of a triangle formula. So the area equals the square root of 3 over 4, side squared. It's an equilateral triangle. That's why it's not base times height. And they're telling you that the side length is x over 3. So all you're going to do is take this side and plug it in for s. So I'm going to get area equals square root of 3 over 4. Instead of s, I'm going to put in x over 3 squared. Now, if you ignore all this, that x over 3 squared looks like something we did in part 1. So we're just going to do that. I'm going to take the 2 to the top and the bottom, and this can become area equals radical 3 over 4 times x squared 3 squared, which is 9. Now, I'm going to do 4. I'm just going to simplify this a little bit. I'm going to put the 3 squared with this, and I think the best way to write it is going to say area equals radical 3 over 4 times 3 squared is 36, because 4 times 9 is 36, and then let's put the x squared right next to it. If you have the x squared on top of the fraction, that's fine too. There's a bunch of different ways to write it. Alright, number 42 is talking about the volume. So the volume of this rectangular prism, this volume is equal to length times width times height, where the length is 2x, the width is 5x over 3, and the height is x. Obviously, it's not going to scale. So I'm just going to plug this stuff in. Volume equals length, which is 2x, times x, or times 5x over 3 times x. So volume is equal to, I'm going to have 10 thirds, because 2 times 5 is 10. And I have 3 x's, so that's x cubed. That's how I would write it. There's a bunch of different ways to write it, but that's how I would write it. 44 wants you to plug in stuff that's going to make this a true statement. So you can pick whatever you want to plug in that's going to make this a true statement. So on top of a fraction, I have 12 x squared y to the 5th. On the bottom, I'm going to fill in the blank. There's going to be 3 blanks, obviously. I'm going to have a something. I'm going to have a number. I'm going to have an x to something. I'm going to have a y to something. So the number I'm going to put in 4, because 12 divided by 4 will give me the 3 that I want. For x, I have x squared. I want that to get bigger to 3. So the only way that the x squared is going to get bigger is if I put a negative number down here, because then I will do 2 minus negative 1, which is going to give me my x to the 3rd, so it has to be negative 1. Now I have 5 here, and I want it to turn it into 2, so I'm going to put 3 y's on the bottom, and that's going to make that 5 minus 3 is 2, so that's it. Alright, 46 says find 3 different ways that you can make x12 y to the 16th from having some different xy's times xy's. So there's a bunch of different ones. I could say x12 y to the 16th, and I could say x0 y0, because that would make it 1. That would work. I could do x to the 14, y to the 18, and those are bigger, so I just have to pick negative exponents. Or I could just split it up. I could say x to the 6th, y to the 8th, x to the 6th, y to the 8th. Any combination that's going to give you 12 for the x's and 16 for the y's. And that's just one option. Alright, so 48 says basically show us how they took the quotient of powers property and that you can basically prove that using the power product property and the negative exponent property. So the first thing I'm going to say is that I can use the negative exponent property to make this a to the m times 1 over a to the n. Now that's just splitting up the fraction. So I haven't done any properties yet. But the negative exponent property can change that to a to the m, a to the negative n. Now the product of powers property tells me I can add the bases, which is a to the m minus n. So that's basically how you do it. That's just kind of like a proof. That's how they start. That's like mathematically how they figured it out, the quotient property. All right, 56 says the continents on Earth move at a very slow rate. The South American continent has been moving about 0.00022 miles per year for the past 125 million years. How far has the continent moved in that time? So all you have to do is multiply this times this. They want you to use scientific notation. So I'm going to take that and write in scientific notation. I'm going to say I'm going to move the decimal 1, 2, 3, 4, 5 decimals to the left. And this, I'm going to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 decimals. Alright. And now I just multiply the numbers together. I'm going to end up with 2.2 times 1.25 is 2.75. And now I'm going to add the exponents. So it's times 10 to the third. And that's it for 50. So you have to write the problems in scientific notation, change them to scientific notation, then multiply, and that's your final answer. And it's actually miles is the label. Alright, so a can of tennis balls consists of 3 spheres of radius r stacked vertically inside a cylinder of radius r and h. Alright, so I kind of trying to make a picture a little bit. Remember, those aren't circles, they're spheres. They're 3-dimensionals. So make sure you understand that that's 3D. So this is 3D, 3D, 3D. I'm just trying to give you like a mental image. So write an expression for the total volume of the 3 tennis balls in terms of R. So I know that the volume of a sphere is 4/3 pi r cubed. So if there's 3 of them, all right, I'm just going to multiply. I'm just gonna multiply it by 3, and I'm gonna get volume is equal to 4 pi r cubed. So that's A. Now B says write an expression for the volume of the cylinder in terms of R and H. Well, the volume is going to be a pi r squared h. So now the interesting part is I know. And guys, if I draw on this ball, like the ball is going to fit snugly. It's going to fit, like if I made that picture a little bit better, the balls are going to fit like tight into here. So they're going to be like as wide. I just didn't do a very great job drawing it. Now, that means that this radius is the same as this radius, even though it doesn't look like it. And the height is going to be 3 diameters or 6 R's. So I get to say that for part B, h is equal to 6r. Alright, so D says what fraction of the can's volume is taken up by the tennis balls. So they want to know what is the tennis ball volume compared to the cylinder volume. So I'm going to put the two formulas. So that's the volume of the tennis ball, and that's the volume of the cylinder. Now in C we said h is equal to 6r. So I'm gonna plug in. Oh, this should be r cubed here. Sorry. So I'm going to plug in 6r for h in the bottom, and it's become 4 pi r cubed all over 6 from the h is going to be 6r times pi r cubed, r squared. Now look, the pi's cancel out. I have 3 r's here. I have another r. Those r's actually all cancel out. So I'm left with just 4 to 6, or 2/3, which means the volume of the spheres is going to take 2/3. There's going to be 2/3 of the tennis balls. The tennis balls are going to fill up 2/3 of the cylinder. Sorry, it was so hard for it to get out of my mouth. Alright, so I'm not going to give you all of a 54, because there's going to be an accuracy problem. Alright, so A is the ratio. You're going to have the whole Earth all over the inner core. Now they're telling you that the whole Earth radius is 5r versus the inner core radius is just r. So I'm going to plug 5r into my my volume. So the volume for the sphere is 4/3 pi r cubed. So you're going to plug in 5r for r. So your volume for A is going to be 4/3 pi, but instead of r, since it's 5 times bigger, you have 5r cubed all over, so over V2, which is going to be the inner core, which is just 5, or 4/3 pi r squared, or r cubed. Now the 4/3 cancel, the pi's cancel. Remember, you have to take the 3, the little exponent has to go to the 5, and it has to go to the r, so it's 125 r cubed all over r cubed. Those cancel. So volume 1 over volume 2, or the total Earth to the inner core, is going to be 125 to 1. So B is going to be on your own, but it's going to be very similar. You're going to have the volume 1, but this time that's going to be the outer core compared to the inner core. So you're going to start with, both of them are going to have 4/3 pi r cubed over 4/3 pi r cubed. I'm going to tell you, you don't change the bottom, but you will plug something into r. I bet it's going to have something to do with 11 over 6r. That's going to take our spot over there. And then you'll be able to do some more math from there to get an actual, it's going to be a fraction. All right, that's it. So, no mistakes on purpose. That's not saying there isn't any. But 54B is accuracy. All right, that's it.